Alright, so let's take a look at this problem. We're supposed to use the formula A equals P times e to the RT, so the continuously compounded interest formula, to find how long it would take for $1,600 to grow to be $2,509 when compounded continuously at 9% interest. So, let's take a step back for a second. Let's just become reasonable human beings here. We started with $1,600. If we're going to end up with 2509, we made about $900 of interest, technically $909. We made $900 of interest off of 1600. Let's do some basic math without the continuously compounded, and let's just say, what if this were 10% just simple interest for a year? Then in year one, 10% is super easy, so I picked that number. It's close enough to 9. 10% interest would be $160 of interest. So that means in year two, slightly more than $160 of interest. Let's just go ahead and call it 200 bucks. So with these rough estimates, then $360 between 2 years. Very rough estimates of just doing very simple math. Nothing complicated at all, just stuff you can do in your head. No calculators necessary. In the fact that what really happened is the amount of interest that we made was $909. So looking at our multiple choice options, with all these values that are less than 2 years, the only one that makes any sense at all is going to be your answer D. Now, this is not a super challenging problem to solve. I'm going to erase this scrap work here, and we're going to go through setting this problem up as intended, where 1600 is P, 2509 is A, and 0.09 is the R. So what this is saying is we have 2509 equals 1600 times the number e to the 0.09 t power. Now, honestly, it probably would not be a horrible idea at this point for you to just grab your calculator and start plugging in those values. And to say, if I had 1600 e, so there's my e to the 0.09 times 1.6. That was option A. Does this give me 2509? Nope. So let me just go ahead and copy and paste that down here, and instead of 1.9, let me try 1.0. Oh, that's even less. So 0.5 would probably be dumb to test too, but let's just go ahead and be dumb. Let's test 0.5. That's not 2509 either. So now let me try 5.0. That does give me 2509. Yeah, 0.3, whatever. Because of rounding, this wasn't going to be exactly 5.0, but it's close enough that we know the right answer. So those are some good strategies to use, is just either common sense, or once you have the formula in front of you, see which answer makes it work. Because remember, back to the first video in this entire class, that's what equations solving is to say what value or values make the equation true. Now, to go through with actually solving this, you'll notice that I actually wrote the multiplication sign in between 1600 and the e. This is to remind us that in order to get the variable by itself, we need to undo that. We need to undo multiplication. We do that with division. I like to write the multiplication sign to remind myself of that because it's tempting to do subtraction sometimes instead. I'm just going to go ahead and leave the fraction over here on the left. So we have e to the 0.09t. Now, the big thing to remember now for solving this exponential equation in front of us is that to undo e, I want the opposite, or the inverse rather, which is log base e, or natural log. So remember, natural log is log base e. And the beauty of that is that log base e and e to a power undo one another. And we'd be left with just 0.09t. Now over here on the left, the natural log is still there because we didn't have an e. And now in order to get the t by itself, we're just going to divide both sides by 0.09. So we should get an answer of t equals the natural log of 2509 over 1600 all over 0.09, at which point we can pick up the calculator. And so we're going to say I have a fraction where I have a natural log with a fraction in it of 2509 over 1600. I'm going to end that fraction, move my cursor down to the bottom where I type in 0.09. I hit enter and I get that answer of roughly 5.0. And we can see why plugging in 5.0 didn't give us the exact answer we were looking for of 2509, but it gave us something close because it wasn't actually 5 years, it was actually 4.998673757 years. Close enough.